In the late 1930s, the world was sliding toward a conflict larger and more destructive than anything industrialized society had ever witnessed. Germany had rearmed, Europe was fracturing, and Japan was expanding aggressively across Asia and the Pacific. The pace of militarization abroad was rising at a speed the democratic world struggled to comprehend. While other nations were mobilizing for total war, the United States was not yet prepared for the scale of what was coming. After World War I, America had demobilized, slashed military budgets, and shifted its national focus inward. The United States Air Corps, the predecessor of the modern U.S. Air Force, existed mostly on paper. Its aircraft inventory was small, outdated, and insufficient for the demands of a coming global conflict. The geopolitical situation was deteriorating rapidly. Germany, led by Adolf Hitler, was broadcasting the future of warfare, a modern, mechanized military built on speed, industrial consolidation, and air-power doctrine. The Luftwaffe demonstrated this during the Spanish Civil War, using air raids and tactical bombing to support battlefield maneuver. The show of force was clear. The next war would be won not by traditional infantry alone, but through air superiority and striking power brought by aircraft manufactured at scale. American planners understood the implications, but the nation was unprepared. The U.S. had the industrial capability, car factories, steel production, a huge workforce, but it was not yet organized for a wartime transition. Aircraft were still built largely by hand, in small batches, not mass-produced like automobiles. Most Americans believed the Atlantic and Pacific Oceans protected them from foreign threats. The military remained professional but small, and the air service lacked the doctrinal investment seen in European and Asian powers. The isolationist mood in Congress and the public reinforced the idea that major war might be avoidable. Across the oceans, other powers were not waiting. Germany's expanding armament industry was turning out modern fighters and bombers in increasing numbers. Japan was doing the same, preparing for territorial expansion across the Pacific. Both nations based their strategy on rapid, aggressive strikes enabled by air power. Their leaders believed that a decisive opening blow could force their enemies into political submission. Air-delivered destruction would set the tone for the war. Meanwhile, the United States clung to the idea that modern war might be small, limited, and distant. A few simulations and strategic studies warned that the nation would struggle if the next war required the production of tens of thousands of aircraft. But these reports did not immediately change government policy. A fundamental shift would only come when events forced the issue. Despite its lack of military readiness, America possessed something unmatched by any other nation: enormous industrial potential. While Germany and Japan worked to expand industries under centralized wartime planning, the United States had a far deeper base of production: factories, highways, steel plants, energy systems, advanced tooling, and the world's most experienced mass manufacturing workforce. If that industrial base could be refocused and unleashed, it could surpass the production capabilities of any other country on Earth. But that was only theoretical, an advantage that would matter only if the nation mobilized in time. Throughout 1939 and 1940, American strategists and political leaders began to realize that time was running out. The fall of France in 1940 shocked the U.S. military and government. A modern democracy had collapsed in mere weeks under a new kind of blitzkrieg warfare. The idea that oceans could guarantee safety began to weaken. The U.S. Air Corps was already planning larger training programs, purchasing more aircraft, and expanding airfields across the country. But progress remained slow compared to the scale of what was coming. President Franklin D. Roosevelt recognized that national defense now depended not just on soldiers, but on manufacturing itself. War in the modern age required aircraft in massive quantities, and that meant building an armaments industry capable of turning raw materials into fighters, bombers, engines, and transport aircraft with assembly line speed. For the first time, leading industrialists were consulted about how to convert peacetime factories for wartime output. Detroit, home of Ford, General Motors, and Chrysler, would be central. Still, the nation was not yet fully committed. Many Americans opposed deep involvement in European conflicts, believing the country should avoid direct intervention. Despite this, preparations continued. Research expanded, production contracts grew, and engineers refined designs for aircraft that could eventually be produced in quantity. It was an uneasy in-between period, accelerating preparation, but not yet full mobilization. Everything changed on December 7, 1941, when the Japanese attack on Pearl Harbor shattered illusions of distance and safety. In a single morning, the United States was forced into a new reality. The question was no longer whether the nation would mobilize for war, but whether it could do so fast enough to survive. At the moment of that attack, the United States did not yet possess the air power required for a global conflict. But the industrial foundations were there, waiting to be activated. The mobilization that followed would become one of the greatest production transformations in human history, and the chapter that turned the United States into the leading air power of the 20th century.
The attack on Pearl Harbor was not just a military shock, it was a national awakening. On the morning of December 7, 1941, Japan demonstrated, with brutal clarity, how air power could redefine the balance of global conflict. Battleships, the traditional symbols of naval might, lay burning and broken. Air superiority, not naval artillery, had decided the outcome of the day. In Washington, military and political leaders immediately understood what this meant. The United States needed aircraft, and it needed them in quantities never imagined before. Within hours, President Franklin D. Roosevelt delivered his famous declaration that the date would live in infamy. But behind the rhetoric, a far more urgent process began. Mobilization orders were issued nationally. Factories received telegrams instructing them to halt civilian production. The War Department drafted emergency plans for aircraft procurement, training, logistics, and industrial expansion. What had been a cautious buildup before the war now became a crash acceleration of national effort. At this moment, the United States had the world's largest industrial potential, but that potential was not yet aligned or coordinated. To fight in both Europe and the Pacific, the U.S. military would need tens of thousands of aircraft, not over years, but as soon as possible. Training pilots, navigators, mechanics, and ground crews would require thousands of additional aircraft just for education alone. The demand for engines, airframes, aluminum, rubber, instruments, and armaments spiked overnight. Congress passed emergency appropriations that released billions of dollars for armament production. Private industry leaders, some of the most influential industrialists in the nation, were summoned to Washington. Henry Ford, William Knudsen, Charles Sorensen, and others were told bluntly, America's survival depended on industry's ability to scale at a pace never before attempted. Knudsen, formerly president of General Motors, played a logistical central role. Appointed as Director of War Production, he helped craft a wartime philosophy that would define the coming years. America would not match Axis production, it would overwhelm it. Air power, tanks, ships, and ammunition would be supplied in such massive volumes that the enemy would be forced into strategic collapse. The U.S. would win not just through military strategy, but through industrial mathematics. From that point forward, nearly every major industrial facility in the country faced a transformative decision. Automobile plants, locomotive works, foundries, appliance factories, machine tool makers, shipyards. Companies that had never built aircraft suddenly received contracts to manufacture engine parts, wing assemblies, hydraulic systems, bombs, and oxygen equipment. Many had no experience in the field, but that was part of the new philosophy. During wartime, specialization could be created on demand. The urgency of the situation generated a remarkable sense of cooperation between government and industry. A huge bureaucratic system evolved almost overnight. The War Production Board was created to organize raw materials, set priorities, assign industrial output schedules, and coordinate national supply. The Army Air Forces, newly elevated as the main wartime aviation branch, issued quotas that were staggering by pre-war standards. Assemblies that once took months would now have to be completed in days. Production runs that once consisted of dozens of units now needed to be measured in thousands or tens of thousands. A massive reallocation of resources followed. Aluminum production was expanded on a scale never seen before. New smelters were constructed near hydroelectric dams in the Pacific Northwest. Steel remained vital, but aluminum became the metal of the air age, light enough for flight, strong enough for war. Rubber, fuel, and lubricants, and aviation-grade materials were rationed for military priority. Civilian automobile manufacturing almost completely ceased in February 1942. The last private car rolled off a Detroit assembly line, and from that point forward, every machine tool, conveyor belt, and stamping press was redirected toward war. The speed of transformation was astonishing. In the first months after Pearl Harbor, engineers and production planners worked around the clock to redesign factories, retool equipment, and install new machinery. The U.S. had never built bombers or fighters in such numbers, and the engineering challenges were enormous. Aircraft required precision manufacturing far beyond automobiles. Riveting tolerances, aerodynamic finish, multi-component engine assemblies, oxygen systems, bombardier instrumentation, all required specialized skills. Tooling had to be invented, workers retrained, and production lines redesigned from the ground up. Yet morale was high. The sense of national emergency created unity rarely seen in American history. Factory workers understood that every plane, engine, and part that rolled out of a factory translated directly into military capability at the front. Recruiting posters declared, "If you can't carry a gun, you can carry a rivet gun." Newspapers chronicled production numbers. Workers compared factory outputs with patriotic competitiveness. The idea of the arsenal of democracy became not propaganda, but lived reality. Training infrastructure expanded just as dramatically. Airfields across the United States were rapidly upgraded or newly constructed to accommodate thousands of incoming pilots and flight crews. Flight schools multiplied. Aircraft that might have served in combat instead became training platforms. New bomber bases rose from empty fields in Texas, Kansas, and California. The skies above dozens of American cities were soon filled with formations of training aircraft in constant rotation. On the strategic front, the United States now faced a two-theater war, requiring different operational doctrines. In Europe, long-range strategic bombing would be central to the campaign against Germany.
In the Pacific, vast distances and naval operations demanded aircraft with extended range, durability, and the ability to operate from island airstrips or carriers. Aircraft designs and production priorities began to diverge accordingly. Heavy bombers like the B-17 and B-24 would be crucial over Europe. Long-range patrol aircraft and carriers would dominate Pacific operations. All of this required one thing above all: output. The United States was now committed to the single largest industrial mobilization in human history. The change was not gradual, it was immediate, sweeping, and transformative. Every worker, engineer, pilot, mechanic, and factory supervisor felt the pressure of time. The nation was not just preparing for war, it was racing against it. By mid-1942, the first wave of mobilization was bearing fruit. Production lines stabilized, tooling systems improved, aircraft began rolling out in accelerating numbers. The early shocks of Pearl Harbor had transformed into the unstoppable momentum of an industrial nation awakening at full power. The war would now be decided not just on battlefields, but on assembly lines, drafting tables, and logistics depots across the United States. America had stepped into the war, and now the engines of its factories would carry the nation forward. When the United States committed fully to the war effort, the challenge was not simply building more aircraft, it was transforming an entire industrial civilization to do something it had never done before. America possessed the world's most advanced mass production system, perfected in Detroit automobile factories. But aircraft were far more complex than cars, and the manufacturing culture had to shift almost overnight from consumer goods to military precision hardware. The first step was national coordination. The War Production Board, headed by experienced industrial leaders, set priorities for every major material: steel, aluminum, copper, rubber, oil, and machine tools. Companies were assigned output quotas and guaranteed government purchasing contracts. This guaranteed demand gave industry the stability to expand aggressively without fear of bankruptcy. Economically, the logic was simple: the United States would spend whatever was necessary to win. Not all factories transitioned smoothly. Automobile production lines had to be redesigned from the ground up. Car engines were cast and machined in large volumes, but aircraft engines required tighter tolerances, lighter materials, and higher operating speeds. Riveting an airplane skin demanded microscopic alignment precision. Bombers required hundreds of thousands of parts per aircraft, 5 or 6 times the component count of a typical sedan. Factory floors had to be redesigned to accommodate larger parts, specialized jigs, longer assembly lines, and new environmental standards. Thousands of workers had to be retrained to understand aircraft metallurgy, mechanical systems, aerodynamics, wiring, and structural assembly. In Detroit, Henry Ford embraced the challenge with characteristic scale. His engineers visited aircraft factories in 1941 to study their methods. They returned unimpressed, not with the quality, but with the lack of mass production thinking. Aircraft plants still used craft techniques, small teams of skilled workers building considerable segments by hand. Ford believed that bombers could be built like Model Ts on moving assembly lines with standardized parts. The result was Willow Run, a facility in Michigan that, once completed, would be capable of producing B-24 Liberator bombers faster than any factory in the world. Ford's rivals, too, expanded or retooled plants to produce aircraft engines, fuselages, wings, and turrets. Some companies went from manufacturing household appliances to precision aviation systems in a matter of months. General Motors became a cornerstone of aircraft engine production. It produced Allison and Pratt & Whitney engines, landing gear, gun mounts, instrument panels, and components for bombers and fighters alike. Buick,
Oldsmobile and Chevrolet divisions each took responsibility for different parts of the war effort. Packard Motor Car Company secured a contract to produce Rolls-Royce Merlin engines under license, engines later used in the P-51 Mustang, one of the most effective fighters of the entire war. Other industries not typically associated with aviation found themselves transformed. Refrigerator factories produced aircraft oxygen systems. Typewriter manufacturers built machine gun components and firing mechanisms. Paint companies developed new coatings to protect metal at high altitude. Machine shops fabricated specialized tooling. The level of national integration was unprecedented, and the efficiency gains were immense. The federal government accelerated the construction of new plants by financing entire industrial complexes outright. Companies operated the facilities, but ownership remained public for the duration of the war. These government-built factories dotted the landscape, often located near rail hubs and power sources. They spread wealth across regions previously dominated by agriculture or small industry. Areas in Texas, Kansas, California, Ohio, Michigan, New York, and Washington transformed into industrial hubs in just a few years. As factories grew, so did labor demands. Local populations could not supply enough labor for the new plants, prompting mass migration within the United States. Millions of Americans moved from rural areas to emerging industrial centers. Cities like Detroit, Seattle, and Los Angeles experienced explosive population growth. Housing shortages forced rapid construction of new neighborhoods, barracks, and temporary accommodations. The labor force grew to include people previously absent from heavy industry, most notably women, whose participation would redefine American society. Worker training programs became central to the mobilization effort. The government established vocational schools and technical courses to rapidly educate new workers in machining, riveting, welding, drafting, and tool fabrication. Aeronautical companies deployed training manuals, filmed instruction reels, and on-site supervisors to ensure consistent production standards. The scale of workforce transformation was staggering. Over 18 million new workers entered the industrial labor force during the war, many with no prior technical experience. While retooling progressed, raw material bottlenecks became a constant concern. Aluminum production, vital for aircraft skins, was especially strained. The solution was dramatic expansion. New smelters rose near Grand Coulee and Bonneville dams, powered by vast hydroelectric capacity. Rubber had to be rationed after Japanese advances cut off Pacific plantations. Chemists, engineers, and manufacturers raced to expand synthetic rubber production. Steel mills increased output to historical highs, and petroleum infrastructure was rerouted to support aviation fuel priorities. Nothing in the war effort existed in isolation. Every aircraft that rolled from a factory required coordination among dozens of suppliers. Engines came from Michigan, aluminum from Washington State, instruments from New England, tires from Ohio, machine guns from Connecticut, and avionics from New York. The result was a national industrial organism, interdependent, synchronized, and capable of growing faster than any Axis power could manage. Even more remarkable was that the transition did not destroy efficiency. Within months, U.S. aircraft production not only caught up to global standards, it exceeded them. Assembly processes improved as factories identified bottlenecks and refined their methods. Standardization grew, defects declined, and the time between prototype and mass production shortened dramatically. The nation was teaching itself to build aircraft at speeds previously considered impossible. By late 1942, the conversion of American industry was well underway. The country was no longer debating whether it could produce enough aircraft to fight a global war. It was now demonstrating that it could produce more aircraft than any other nation in history. And this transformation was only the beginning. The next challenge would be to turn these expanding industrial capabilities into operational air power, delivering aircraft to training schools, bases, and overseas theaters at a pace that would bend the direction of the war.
As the United States fully committed to war, the country underwent one of the most dramatic industrial transformations in human history. The factories, workshops, and assembly lines that had once produced refrigerators, automobiles, washing machines, and radios were now redirected toward building the machinery of global conflict. It was not a gradual shift. It happened with the force of national urgency, and within a matter of months, America became the greatest war producer the world had ever seen. Before the war, the U.S. Army had been small and under-equipped, and many commanders feared the nation was years behind European military powers. But America had a different kind of strength, one that could not be measured in divisions or artillery pieces. No nation on Earth possessed more steel, more coal, more aluminum, more railways, or more factories built for large-scale production. Once mobilized, this industrial depth became a weapon in its own right. President Roosevelt called for the country to do the impossible: build more tanks, more ships, more artillery, and more bombers than the Axis could ever replace. And remarkably, industry leaders did not argue. Companies that had spent decades competing now worked side by side under government direction. Production boards coordinated materials, labor, and shipping, ensuring every bolt, plate, and engine found its place in the war effort. Automobile manufacturing was the first sector to change. Civilian car production ceased entirely. Ford, Chrysler, General Motors, Packard, Studebaker, and dozens more received orders not for sedans and coupes, but for engines, armored hulls, machine guns, bomber fuselages, and military trucks. Factory floors were redesigned overnight. Stamping machines were repurposed, and the workers who once built luxury interiors now laid down steel for tanks and aircraft components. The most famous example of this change was the Willow Run plant in Michigan, built and operated by the Ford Motor Company. Designed specifically to mass-produce the B-24 Liberator bomber, Willow Run became a symbol of what American industry could do when given a single mission. The assembly line stretched more than a mile in length, and at its peak, the factory turned out one fully completed bomber every 59 minutes. Where a bomber once took weeks to construct, the United States now produced them in hours. This was the moment when the assembly line, first invented for cars, became a weapon of war. The workforce powering these factories was unlike anything the country had ever seen. Millions of men were gone, drafted into uniform and sent overseas, leaving industrial labor shortages at home. To fill the gap, women entered heavy industry in unprecedented numbers. Many had never worked a factory job in their lives, yet they learned the skills needed for welding, riveting, machining, electrical systems, and precision assembly. Images of women on the production lines soon became a national symbol of the home front's determination. They were not just replacing male labor, they were redefining the American workforce. Parents, teenagers, immigrants, and retirees all found work in the roaring factory complexes that now operated day and night. Cafeterias ran around the clock. Buses transported workers from distant towns. Housing development sprang up around the largest plants as thousands relocated from rural areas to take part in the national effort. People understood that the work they performed was not theoretical. Every bolt they tightened, every engine they finished, every wing they riveted might determine whether a bomber crew returned from a mission alive. By mid-1943, the scale of production defied belief. American factories turned out nearly 100,000 aircraft in a single year, along with tens of thousands of tanks, hundreds of thousands of trucks, and billions of rounds of ammunition. Shipyards launched naval vessels faster than German submarines could sink them.
Freight trains and cargo convoys stuffed with equipment streamed toward ports on both coasts, each one a visible reminder that industrial power had become as decisive as air power or ground combat. Germany and Japan had experienced early wartime success, but their economies could never produce in comparable volume. They lacked the natural resources, the industrial space, and the mass assembly capabilities that the United States possessed. Their factories often relied on manual craftsmanship, small workshops, or limited machine tools, processes impossible to scale when facing a continent-sized economy dedicated to total war. Even when Germany's output increased, the Allies could replace losses many times faster. This industrial advantage changed the nature of the war. The United States could suffer setbacks, absorb heavy losses, and still send more aircraft, more pilots, and more supplies into combat the next week. The Axis could not. A single destroyed German aircraft factory had lasting consequences. A single Allied production setback was barely noticeable against the avalanche of goods still flowing out of American ports. The result was something entirely new. A world where factories, not battlefields, became the ultimate measure of military power. The arsenal of democracy was not just manufacturing machines, it was manufacturing inevitability. Every finished bomber rolling out of Willow Run, every tank rolling off a Detroit assembly line, every cargo ship sliding into the Pacific brought the United States one step closer to strategic dominance. By mid-1943, this engine was running at full capacity. The planes were built, the fuel was refined, and the trained crews were ready. Now the vast industrial strength of the United States would move from assembly lines to the front lines. The air war that had once been dominated by the Axis was about to shift permanently, because for the first time in history, a nation could replace entire air forces faster than an enemy could shoot them down.
The transformation of America's industrial workforce during World War II was one of the most profound social changes in the nation's history. When the United States entered the war, millions of young men were drafted into the armed forces, leaving behind empty factory floors and critical labor shortages. Industries building aircraft, tanks, naval vessels, munitions, and vehicles suddenly found themselves in desperate need of workers. The country faced a choice: slow production or redefine who could stand at the assembly line. The decision was made quickly. America opened the doors of heavy engineering to women on a scale that would have seemed impossible only a few years earlier. Before the war, many American women had worked in clerical roles, teaching, domestic service, or small-scale manufacturing. Heavy engineering, steelwork, welding, riveting, and machining were considered jobs for men, jobs that society had assumed women either could not perform or would never need to do. But wartime necessity swept away those assumptions. The government launched recruitment campaigns, calling women directly into service on the home front. The posters and radio broadcasts carried a simple message: the country needed them, and the war would not be won without their labor. Factories began hiring women in enormous numbers. Some arrived with no industrial experience whatsoever. Others had worked on farms or in small workshops, but none had ever been handed the responsibility of building engines, assembling anti-aircraft guns, or welding bomber frames. Training programs were established across the country, and thousands of schools were converted into technical workshops, where women learned the use of precision measuring tools, industrial drills, lathes, welding torches, and riveting guns. What they lacked in background, they made up for in discipline, patience, and endurance. The impact was immediate. Within a year, almost half of the American aircraft industry workforce consisted of women. In some factories, they made up more than 60%. The famous cultural icon, Rosie the Riveter, emerged from this period, symbolizing the millions of women who worked long shifts, not for recognition, but because the war demanded it. The slogan, "We can do it," was not simply a poster, it was a national declaration. Life on the factory floor was demanding. Many women worked 10 or 12-hour shifts, 6 days a week. Housing shortages in industrial towns forced workers to sleep in crowded apartments, converted schools, and in some cases, temporary housing built near major plants. Childcare became a nationwide challenge. Some factories opened on-site nurseries, so mothers could leave their children in safe care while contributing to war production. Others relied on extended family networks or neighbors. Everyone adapted because there was no alternative. Despite the hardships, the sense of purpose was overwhelming. Workers understood that they were not simply building machines, they were contributing directly to the survival of friends, sons, husbands, and brothers serving overseas. One factory worker later recalled how every plane she helped assemble felt personal, because someone's life would depend on it. That attitude spread across the industrial workforce. Quality control improved, error rates dropped, and production accelerated. Women worked as welders on ship hulls, machinists in engine plants, assembly workers on tank production lines, and riveters on the great aircraft of the era. Engineers who once doubted their ability found themselves re-evaluating their assumptions. The results spoke for themselves. American factories produced more aircraft, ships, tanks, and vehicles than any country in history, and women were vital to that achievement. In the bomber plants of California and Michigan, women riveters stood beneath massive wings, pressing steel together piece by piece. In shipyards on both coasts, teams of welders, many of them in their 20s, helped assemble the carriers and Liberty ships that sailed across the Atlantic and Pacific. These contributions were not simply symbolic. They altered the global balance of military production. Germany and Japan struggled with labor shortages throughout the war, relying on forced labor, prisoners, or youth conscription to fill their factories. The United States, by contrast, brought a new labor force into industry, expanding its productive capacity even while millions of men served in uniform. American output climbed past anything the Axis could hope to match, and much of that output rolled out of factories where women formed the backbone of the workforce. The shift had lasting consequences beyond the war itself. Women proved they could master industrial work on the same level as their male counterparts. Though many would leave the factories once the war ended, their presence on the production lines changed expectations forever. Millions had earned their own wages, developed technical skills, and entered roles previously closed to them. The idea of what American women could do and what society could expect from them had changed permanently. By the mid-war years, the female workforce had become a national institution. Posters encouraged women not only to join factories, but to stay until victory was secure. Newspapers celebrated record production achievements, and morale campaigns reminded workers that every finished engine, every welded hull, and every completed bomber brought the country one step closer to defeating the Axis. Women had gone from bystanders to essential participants in the nation's war machine, and the factories they powered would supply the aircraft that turned the tide in the skies over Europe and the Pacific. When historians later tried to explain how the United States became the dominant air power of the era, many pointed to the technical innovations, the sheer scale of production, and the strategic use of resources.
But behind all of that stood millions of workers, many of them women, who had stepped into roles no one had expected and performed them with remarkable success. The arsenal of democracy did not run on machines alone. It ran on the determination of a society that knew the war could only be won if everyone contributed.
Even with massive factories producing aircraft, engines, and weapons at unprecedented speed, the United States faced another monumental challenge: getting those machines, supplies, and trained crews to the front lines. Winning the war would require not just building air power, but delivering it, sustaining it, repairing it, fueling it, and organizing it across continents and oceans. The war was not fought on American soil. It was fought thousands of miles away, in England, North Africa, Italy, the Central Pacific, and beyond. The United States had to invent a supply system large enough to shrink the world. Before World War II, the U.S. Air Corps was small and did not have experience in projecting aircraft power overseas at scale. Air bases were limited, logistical systems were modest, and few in the military had planned for a global conflict requiring the movement of hundreds of thousands of aircraft and millions of tons of fuel, spare parts, food, tools, ammunition, and personnel. The industrial buildup inside the United States was only the first half of the mobilization. The second half was building the highways, ports, depots, pipelines, and airfields necessary to wage a global air war. The transformation began with training. Pilots, navigators, mechanics, and ground crews had to be prepared in enormous numbers. The United States expanded small military airfields into vast training complexes stretching from Texas to California. Entire towns became aviation cities, where student pilots lived, ate, flew, and trained day and night. Civilian flight schools were contracted to produce pilots. Universities adopted military engineering courses. Aircraft manufacturers helped instruct mechanics and assembly specialists who learned to repair the planes they helped build. By 1944, the United States was producing thousands of new pilots every month. On the ground, technicians learned to maintain engines, replace wings and landing gear, calibrate instruments, and rebuild damaged aircraft that returned from combat. Unlike the Axis powers, the United States understood early in the war that air superiority was not just about flying the best planes, it was about having trained crews and mechanics who could keep them flying every day under every condition. Logistics soon became an engineering marvel. The U.S. Navy and Merchant Marine built and operated thousands of cargo ships, tankers, and supply vessels. Liberty ships built in record time in American shipyards carried aircraft parts, fuel, spare engines, bombs, vehicles, and rations across the Atlantic and Pacific. Entire fleets became floating supply lines that never rested. A bomber flying over Europe consumed enormous quantities of material, thousands of gallons of fuel, ammunition for its machine guns, replacement parts, and crew equipment. That meant the factories back home had to keep moving, and the supply convoys had to keep crossing the ocean. At the same time, construction crews and military engineers worked around the world to build new air bases. In Britain, the countryside was transformed by the arrival of the U.S. Army Air Forces. Small villages that had never seen American soldiers suddenly had massive airfields built beside them, hosting hundreds of bombers, trucks, mechanics, and flight crews. England became the largest aircraft carrier in history, an unsinkable launch platform for the coming air war against Germany. In the Pacific, the challenge was different. Instead of a concentrated base of operations, the U.S. military faced a chain of islands that had to be captured one by one. Seabees, naval construction units, landed on newly taken islands and immediately began building runways, hangars, repair facilities, barracks, and fuel depots.
Within weeks, aircraft were landing where jungle or volcanic rock had stood before. In some cases, runways were carved into coral or built on floating pontoons, proving that no terrain was too remote or too hostile for American engineering. Fuel was another challenge. Bombers and fighters required aviation gasoline in unimaginable quantities. To sustain operations, the United States built supply pipelines in England, fuel depots in North Africa, and tanker fleets to keep Pacific airfields supplied. Thousands of rail cars crossed the country every day, carrying fuel from refineries to ports. Nothing in the air war functioned without this constant movement of resources, and the logistical system behind it was almost as impressive as the aircraft themselves. Every bomber group, every fighter squadron, every transport wing depended on supplies that moved through a global web of ports, trucks, railroads, warehouses, depots, and maintenance centers. When an aircraft suffered damage in combat, ground crews worked through the night to repair it. The goal was simple: get the plane back in the air by morning. If the damage was severe, it could be flown to major repair depots where teams rebuilt it from nose to tail. Not even shot-down aircraft were completely wasted. Engines, propellers, instruments, and armor plating were salvaged and reused. This system allowed the United States to do something no enemy air force could match: operate continuously at high intensity without exhausting its strength. German and Japanese units often struggled to replace lost planes and crews, while American units returned from missions, refueled, rearmed, repaired, and were ready to fly again the next day. The difference between running out of replacement aircraft and having another waiting on the runway was the difference between strategic defeat in the skies and victory. American strategists understood that air power was not just about winning dogfights or bombing targets, it was about grinding down the enemy through sustained pressure, day after day, month after month. That kind of pressure required bombers in the air, crews on the ground, supplies in the depots, and a logistical machine that never stopped moving. The U.S. military learned to wage war as an industrial system, one where the front lines were only the final stage of a much longer chain of construction, manufacturing, training, and transport. By the middle of the war, that system was functioning with unstoppable momentum. The factories at home produced, the ships delivered, the engineers built, and the aircraft launched. No other nation could match the scale or the coordination. When history later judged the war, many would argue that battles were won not just in the skies or at sea, but in the warehouses, shipyards, and supply depots that kept America's planes flying far from home.
By late 1943, American air power was no longer just growing, it was reshaping the strategic balance of the war. What had begun as a desperate scramble to build an air force capable of surviving was now developing into a machine that could fight across entire continents. The factories of Detroit, Chicago, and Los Angeles were operating around the clock. Every day, more aircraft left the production lines than many nations had built in entire years. But the story of air superiority was not simply one of numbers. It was a transformation in doctrine, leadership, technology, and the brutal real-world testing of thousands of young airmen who were learning that air power was no longer the supporting arm. It was becoming the main weapon of the Allied war effort. American strategy shifted from tactical reaction to grand strategic offense. Instead of bombing factories near the front lines, the United States set its sights on the heart of Axis industry itself. Germany's synthetic fuel network, ball bearing production, aircraft assembly centers, and transportation hubs became the target list. These were not symbolic objectives. They were the arteries and lungs of the German war machine. If American bombers could destroy them, Germany's armies, tanks, and aircraft would simply run out of the ability to fight. Yet achieving that vision was anything but inevitable. Heavy bombers like the B-17 and B-24 could carry enormous loads of explosives deep into enemy territory, but reaching a target was only half the mission. Returning home alive was the other half, and in 1943, many air crews learned how uncertain that second half could be. Flying at high altitude in tight formations, bomber crews faced flak that tore through aluminum skin like paper, machine gun fire from German fighters, and weather that could blind entire formations without warning. Missions to Schweinfurt and Regensburg demonstrated the reality of deep penetration bombing. Dozens of bombers failed to return, disappearing into clouds of smoke or crashing into fields thousands of miles from friendly lines. The air war was no longer theoretical. It was personal, costly, and deeply unforgiving. What changed the momentum was the arrival of long-range fighter escorts. Aircraft like the P-47 Thunderbolt and the P-51 Mustang could now fly alongside bomber formations from takeoff to target and back again. This one change began to rewrite the story of the air war. German interceptors could no longer concentrate on unprotected bomber formations with impunity. Every attack risked being intercepted, chased, and shot down by American fighters operating far beyond what had been possible only months earlier. German losses began to rise sharply. Their Air Force was losing irreplaceable veteran pilots at the exact moment they needed them most. The skies of Europe, once contested, now leaned heavily toward Allied dominance. But the transformation was not purely technological. Airmen themselves were changing. The average American pilot in 1943 was harder, more experienced, and had survived missions that few could have imagined at the beginning of the war. Air units had developed manuals, procedures, and strategies based on real combat experience. They refined formation flying, improved the timing of bombing runs, and explored new methods for precision attacks. Radar navigation, bomb sites, and weather forecasting advanced rapidly because mistakes in those areas cost lives. The learning curve was steep, but it was also decisive. Factories back in the United States evolved just as rapidly. What had once been ordinary peacetime manufacturing now resembled a vast automated ecosystem. Assembly lines produced wings, fuselages, and engines in enormous modular sections. Quality control expanded. Logistics systems synchronized production and delivery schedules, and the aircraft industry became a national enterprise stretching across every time zone. Rail lines shipped components with military priority. Trade schools trained thousands of new welders, machinists, and metal fabricators. Women and minority workers took roles once denied to them and pushed output beyond all expectations. Every bomber sent overseas represented not just metal and wiring, but the effort of entire communities who understood that what they built would help decide the future of the world. By early 1944, the signs of change were visible even in occupied Europe. German soldiers noticed fewer aircraft on their side and more in the sky marked with the white stars of the U.S. Army Air Forces. Industrial production inside Germany struggled to keep up. The constant threat of bombing forced factories to disperse, relocate underground, or rely on emergency production methods. Trains ran less reliably. Fuel grew more precious with every passing month. German strategic planners understood what was happening. They were being outproduced, outsupplied, and slowly bled by an enemy who seemed able to build faster than they could destroy. American strategists saw something too. Air power was finally delivering strategic leverage on the ground. Every destroyed ball-bearing factory weakened tank production. Every fuel depot set ablaze meant fewer aircraft in the sky the next week. The long-promised theory of strategic bombing, that an air force could cripple an enemy without first defeating their armies, was beginning to show results. But even in victory, the cost was visible. Airfields across England were lined with new bombers ready to fly.
But they were also lined with empty spaces where aircraft had failed to return. Letters home were written every night. Commanders held briefings where the room contained fewer faces than the week before. The price of air supremacy was being paid by a generation of young men who stepped into cold aluminum fuselages knowing odds were uncertain, but mission remained constant. Still, momentum was real. The United States now possessed something rare in military history, a force capable of projecting destructive power across an entire continent daily, without requiring ships, artillery, or infantry assaults. Each dawn brought new missions. Each mission weakened the enemy's capacity to resist, and with every returning bomber, American leadership saw the path forward. The air war was entering a new phase. The United States Air Forces were no longer preparing for the decisive assault. They were shaping the battlefield for it. And soon, the greatest amphibious invasion in history would depend on the control of the skies that American pilots, factories, and workers had fought so hard to achieve.
By 1944, the strategic air war had reached its decisive phase. The United States was no longer building strength, deploying cautiously, or learning through painful early battles. Now the American air arm was striking with a level of intensity and scale no nation had ever seen. Every day, the runways of southern England thundered as waves of bombers and fighters climbed into the gray morning skies. Their mission was clear: finish the job. Cripple the German war machine so completely that the coming Allied ground invasion would face an enemy drained of fuel, short on weapons, and unable to maneuver. Air power, once an unproven theory, was now the cornerstone of the Allied plan to liberate Europe. The transformation was measurable in numbers, but it was more visible in effect. Germany's adversaries had launched thousands of sorties before, yet never with such precision, coordination, and relentlessness. Targets were no longer chosen at random or for propaganda value. They were selected based on detailed intelligence, showing what Germany could not afford to lose. Oil refineries, locomotive yards, aluminum mills, synthetic fuel plants, tank factories, and aircraft assembly complexes became the priority. A single successful raid on fuel production could ground hundreds of German aircraft, turn panzer divisions into stationary targets, and halt troop movements for days. Every strike was part of a larger operational logic. The U.S. Army Air Forces understood that D-Day, the largest amphibious landing in human history, could succeed only if the German response was weakened before the first soldier stepped onto the beaches of France. Air commanders worked backward from the invasion date, calculating how much damage had to be inflicted beforehand. That calculation revealed a sobering truth. Germany had to be broken from the air, not after the invasion, but before it began. To accomplish that, American aircraft spread across the continent like a moving storm front. Daylight precision raids hit factories from Munich to Bremen. Night operations by the British RAF compounded the destruction. Railway bridges were bombed faster than German engineers could rebuild them. Entire cities devoted to armaments were forced to operate under constant threat. Workers sheltered in tunnels while flames rose above ground. The strategic pressure became relentless, and even German leaders began to recognize the inevitability of decline. Yet this period also tested the American airmen more severely than ever before. Missions now regularly stretched across hundreds of miles deep into defended territory. Crews faced tighter flak belts, faster German fighters, and increasingly desperate tactics designed to stop the bombers at any cost. The Luftwaffe deployed rocket-armed interceptors, reinforced night fighter defenses, and sent aircrew into the skies knowing replacement pilots were scarce. What had once been daring but manageable opposition was now a sharp fight between two forces giving everything they had left. Though Germany innovated, the strategic balance had already shifted.
American escorts patrolled higher, farther, and more aggressively as P-51 Mustangs and late-generation P-47s cleared the skies. Long-range fuel tanks expanded their reach across Europe. Now, the Luftwaffe could no longer choose when to engage. American fighters came to them. Every battle cost Germany more trained pilots, more aircraft, and more irreplaceable experience. Meanwhile, back home, the industrial engine powering all of this continued increasing output. Aircraft factories delivered new fighters and bombers far faster than the enemy could destroy them. Production workers learned efficiency techniques that saved seconds, and those seconds multiplied into thousands of additional aircraft per year. The United States had discovered the power of industrial war. Weapons did not have to be perfect. They had to be numerous, reliable, and delivered faster than the enemy could destroy them. That equation favored America overwhelmingly. Intelligence advances sharpened the effort. Aerial reconnaissance mapped factory layouts, fuel depot locations, and transportation bottlenecks. Photo interpreters learned to detect repairs, emergency power hookups, and hidden relocation sites. Missions were planned with greater precision, and errors that once cost lives became rarer as experience filtered into doctrine and training. Technology also helped. Radar-assisted navigation and improved bombing systems enabled strikes through clouds, smoke, or night conditions that had previously rendered missions ineffective. Air power was becoming a scientific instrument, precise, methodical, and strategically targeted. By spring 1944, the results were visible. German aircraft sat grounded for lack of fuel. Armored divisions rationed supplies and moved only when absolutely necessary. Factories relocated into tunnels and mountains, slowing production to a crawl. The railway network, Germany's key internal artery, was shattering under the constant bombardment of bridges and junctions. Supply could not keep pace with demand, and every strategic shortfall compounded another. The Luftwaffe, once feared across Europe, was losing control of the air faster than it could rebuild. On Allied airfields, crews felt the change too. The ratio of returning aircraft slowly improved. Missions that once cost dozens of bombers were now survivable, though still deadly. Briefing officers could finally tell crews that the strategy was working, not in theory, but in measurable results. Bombing reports showed factories operating at half capacity or less. Analysts tracked fuel production collapsing month by month. The enemy was being worn down, not by a single decisive blow, but by the accumulated weight of thousands of missions flown by tens of thousands of American airmen. But no one believed the war was won in the air alone. The air campaign was clearing a path for the armies waiting in England. Hundreds of thousands of soldiers preparing to cross the Channel. Their lives would depend on the success of the air war. Every destroyed refinery meant fewer German tanks facing them. Every collapsed bridge meant fewer reinforcements arriving at Normandy. The air forces understood the stakes clearly. If they failed, the soldiers waiting below would face a stronger enemy. If they succeeded, the invasion had a chance to succeed. As the weather warmed and the days grew longer, Allied commanders knew the air war had reached its critical moment. The skies had been contested for years, but now the balance of power had shifted unmistakably. American air superiority was not a prediction, it was a reality visible across every front. Germany could still fight, but each month it fought with fewer fuel, fewer aircraft, and fewer experienced pilots. For the first time since the war began, the Axis no longer controlled the tempo. The Allies did. And the storm that had taken shape in the factories of America was now breaking across Europe, paving the way for the final phase of the war, the return to the continent. The next phase would be fought on beaches, hedgerows, and ruined cities, but it would begin in the sky, with the hard-won dominance American airmen had purchased mission by mission, loss by loss, until the skies themselves became the Allies' greatest weapon.